In this video, you will learn about pre-processing text data. Remember that pre-processing text data was the second step in our recipe. So the first step was to define what a document is. And now you will learn about pre-processing text data. And the third step in our recipe is about applying the methods on our text data. So we have different steps in pre-processing. First, we can clean the text. For example, we can ignore or remove any unwanted characters. So we can ignore the casing of words, and we can remove the HTML markup and non-words, for example, special signs, and so on. And perhaps we can also drop emoticons, but sometimes we don't want that. Second, we can do what is called tokenization, and I will talk more about that later. And we can also remove stop words, which I will also talk more about. And third, we can stem and limitize the words, and I will also talk more about that. So which pre-processing steps that are important, it depends on the problem you will solve and the text data that you have. So it's important to go through the text data and think about what do you actually need from that text, and think about what problem do you have and what do you need to solve that problem. But I think it will make more sense when we have talked about all the pre-processing and also the applications of text data. So first, we need to clean the text. So clean the text means we can ignore the casing of words, for example. We want that movie with a capital M and movie with a small m is the same word. So normally we will change all letters, all letters to lowercase. Sometimes we can also see that there is, especially if we scrape some data, that there can be some HTML markup still in the data, the text data, and we don't want that. So we will remove the HTML markup, and we will see in our review data that we will look at that there are actually some HTML markup here. So third, there may be some non-words. So non-words, what do I mean with that? That's characters that are not words or numbers, so non-alphanumeric characters, and they are typically not important for text data analysis. So we might drop them. So there are some exceptions. So the exceptions can be emoticons, and emoticons, for example, with sentiment analysis in text, they are very important. So we wouldn't like to drop emoticons. And another exception can be dollar signs to indicate a price, and the punctuation that are in the price to indicate decimals in the price. So we need to think about the problem that we want to solve, and then go through the text to see what do we actually need to remove. That's also what I write here. It all depends on the problem you want to solve. And one remark is that we want to, if we want to remove any non-alphanumeric characters, then we should not remove it before we tokenize, because it may corrupt the tokenization. That is the next step, tokenization. So I will talk more about that. So, and the last item here, can you think about other stuff that we need to remove? So it's not a complete list I have here. It all depends on the problem you want to solve and the text data that you have. So how do we actually change to lowercase, for example? That is very simple. We have a review, I call review, and I can just type dot lower, and then all letters will be lowercase. How do we remove HTML markup? So we can remove the HTML markup with regex. So we define a regex pattern that will find all the HTML markup in our text, and then we use our sub function in the regex package to find all the places where there are HTML in the text, and then replace it with this space here. So we take our text from before, we view low, and then we match all the text where all the text which is between these two signs here, and then we replace it with a space, and we get this new text which is free from HTML markup. And how do we remove all characters that are not words or numbers? So all alphanumeric characters. We can also do that with a regex pattern. So here we find all the non-alphanumeric characters. So this is regex for alphanumeric characters, and when we have this sign in front, then it's all the non-alphanumeric characters. And we also match on the white space, and so we find all the places where non-alphanumeric characters, and we replace them with a blank spot here. So the text we get then is this review cleaned text without any alphanumeric characters and without HTML, and also with only lower case letters. So what we did here was also to remove any emoticon that would be in the text. I did this for pedagogical reasons, so we wouldn't need to worry about that. But in the applications that we will see below, we will actually benefit from having emoticons as well, because we would like to predict sentiments of these texts. But for simplicity, I have removed them here. Okay, so the last item here, the other stuff. As I have said, there may be other things you need to remove before you are ready to move on in your preprocessing. And again, it depends on the text that you're dealing with and the problem you want to solve. So I can't repeat it enough. Investigate the text and figure out what do you need to keep and what is not important in your text. So that is just getting to know your data. Okay, so now we have our different cleaning steps, and I can combine them in a function and then apply this cleaning function to all reviews in our data set. So I can work with it later. So here in this code, I have combined our cleaning steps in our cleaner function. And then I apply this cleaner function to all the reviews in our data frame. And then I save them in the review column again. So, and the result is this. So you can see that all the different reviews now have only lowercase case letters, and all the other cleaner steps has also been applied to these reviews. Okay, so the second step in pre-processing is a step that you don't need to do every time. So this depends on what problem you have, but you need to know what it is and what it does. So tokenization is about splitting the document into meaningful elements, what we call tokens. So normally tokens can be thought of as words in a sentence, and it can also be thought of as sentences in a text. But normally it is words in a sentence and in a text. So the simplest tokenization you can do is to split your cleaned document, so the reviews we have just cleaned, and split them at its white spaces. So we can do that here. Just use the dot split method, and then we with this example review we have here, we then get a list of all the words in this review, and they are split by the white space. So this is a very simple way to tokenize, and in some cases it might not be enough to tokenize like this. So we might think of a situation where abbreviations like PhD is tokenized in a wrong way. If we before we actually tokenize, we also, for example, remove all the non-alphanumeric signs, and we might find that this split function splits the PH and the D into two tokens, and we don't want that. And we can also, for example, if there is a dollar sign to indicate a price, then it might be split in the wrong way, and stuff like that. So the NLTK library, which is the natural language toolkit library, has some tokenizer packages that can do the work for you in a more advanced way. So the most simple tokenizer they have is the word tokenize function, which will split the words in a bit more advanced way in the split function than the split function. And we also have a treat tokenizer, for example, that is good with Twitter data because it will keep the hashtag intact. And you can also define your own tokenization pattern using this regex p tokenize function, where you can define exactly how you want to split your text into different tokens. But normally split is also just fine. So if we try to use the word tokenize function, we will see that it also splits the review into the words, and it looks very similar to the split tokenize function. So stop words are words that are extremely common in all text, in the text data that you have. So because they are so common, they probably bear no useful information about the text. So to keep it simple, we want to remove them. And examples of stop words are is, and, has, like, stuff like that. So here you can also use the NLTK library of 127 English stop words. So this NLTK library is a very popular Python package for natural language processing. So it's good to know this package. And to remove the stop words in our review, we can download the stop words like this, and then import the stop words package, and store the stop words, the English stop words in stop like this here. And then for each token in our review tokens here from before, we can see whether the token is in the stop words list, and if it's not, then we will append it to our new review no stop list here, and you can see the list down here. So the difference between this review no stop list and the review tokens list, you can see here, down here. So if we print the length of the two lists, you can see that the review tokens list are much larger than the review list with no stop words. So we have removed a lot of stop words in this list, and it makes it way easier computationally to manage our text analysis. So a third step in pre-processing is stemming and lemmatization. So first, stemming. Stemming is the process of transforming a word into its root form. So this will allow us to map related words to the same stem, and why is that important? So examples are if we have runners, running, it will become runner, run, and if we have wonderful, it becomes wonder. So you can see that we have some words that are very similar, and we would therefore also like to treat them similarly in our text data analysis. So we can do that by stemming them, and then they will sometimes become the same word. That will also reduce the dimensionality of our text data, so it will be easier to compute. our analysis. So to stem, you can use the Porter stemmer in the NLTK library, and this Porter stemmer is the most popular and the oldest stemmer. So with stemming, we generally just remove this suffix of the word. So it's a very simple method, and it might give us some a bit weird results sometimes. So if we look at how to do it, you can see why. So we can use the Porter stemmer by going to the NLTK library. So we will save that to Porter, and then for each token in the review no stop list here, we will stem that token or that word, and then we will save it again in the review stemmed. So if we go through this list, you can see that the stemmer is not perfect. So it has changed some of the words into meaningless words. For example, family with an I instead of a Y, and sometimes it also remove letters in the end of the words. So a different method you can use is lemmatization. So as you just saw, stemming can create non-real words in some cases because it just removed the suffix of the word. So instead, lemmatization is more advanced, and it seeks to find the grammatically correct form of the word, which is called the lemma. So if we have this example, coding, code, coded, they will all be lemmatized to code. And this is really nice because before we had 3 different words, and now we only have 1 word with the same meaning. So it really helps us with the computation of our text data analysis. So one con of the lemmatization is that it demands more computer power, so it can be slow. And some smart people have investigated that actually there are a little difference between stemming and lemmatization on the performance of text classification. So actually it might not matter that much whether you use stemming or lemmatization, and it might not matter that much that you actually get some non-real words in the stemming. But if we want to use lemmatization, then you can use the WordNet lemmatizer from NLTK. And WordNet is a large lexical database of English words. So you can think of it as a dictionary. And we can use that in Python like this. So we download the WordNet database or the WordNet dictionary, and then we save this WordNet lemmatizer in WNL to ease the coding. And for each item in or each token in our list, we lemmatize the token. So in the list, below here, you can see that now it has actually lemmatized, for example, family and friendly into the right word with a Y. And you can go through the list to see that it has done a better job to find the right root of the word. For example, also miracle here with an E in the end.